My life has been an utter failure. I was the first Asian to bring home the Nobel Prize in the scientific field. I thought I would build true science in our country. All we have now is a legion of camp followers of the West. There can be no salvation, no real advance at this rate.
He was one of India's greatest physicists, the acknowledged leader of the early scientific movement in this country. Noble Laureate, he is renowned for a discovery that bears his name, the Raman effect. Why then, in the twilight of his life, does he look back not with pride and satisfaction, but with pain? He was a man of strong convictions and innovative ideas, many of which are as relevant to Indian science today as they were at the turn of the century. This film is not just about the life of a famous man now no longer with us, but also a tribute to his genius. This is a film on the legacy of Sir V Raman. The young Raman was curious by nature. He wanted to know more about everything that he saw and heard. For the rest of his life, this curiosity, combined with an inherent love for nature, drove him to study her many facets. Even at the age of 82, he was exploring new vistas as actively as he did as a child. For him, science had always been the key to understanding the workings of the world around him. Fascinated, he mastered such classics as Ganot's physics. There is a story that late one night, despite high fever, he refused to sleep till his father, a science lecturer, fetched a Leyden jar from his college and showed him how it worked.
See, a large amount of charge is accumulated at the bottom. You connect this to the electrode, it gets discharged.
Apriya, there's a spark.
Raman was born near Tiruchirappalli in Tamil Nadu in 1888. From there the family moved to the coastal town of Visakhapatnam when he was 4 years old. The sun, the sea, nature in all its primordial beauty here must have first stirred the young boy. He began to ask questions. His father encouraged his curiosity. As Raman's thirst for knowledge grew, he was spurred to take science up seriously in later years.
What are you doing now, young man?
Sir, I'm trying to work out a new method of measuring the surface tension of liquids.
New method? Why?
Because by the usual method, either the drop is not steady or it falls down in the middle of the observation. So I thought if I could photograph the drop profile, it would be easier to calculate the surface tension.
Sounds ingenious. Carry on.
Oh, sir, Professor Jones, sir. One moment, please.
Yes?
Some time ago, I'd given you a paper of mine for comments.
A paper?
Yes, on unsymmetrical diffraction bands when the incident light is oblique.
Really? Ah, yes. Perhaps you did. Well, it is nothing much to go by. Nothing at all. Carry on with your work.
Raman was not discouraged by Professor Jones's lack of interest. Instead, he took the initiative and sent his paper to one of the most respected scientific journals, the Philosophical Magazine, in London. And it is to his credit that he had enough confidence in his first independent experiment to be able to send his findings to such a reputed magazine. For then, as now, education was a means towards a degree. Students were not encouraged to think independently or to use their initiative. Colleges in India did not have a tradition of research. Which of course brings us to a very fundamental question.
What is research? It is only seeking after knowledge. Knowledge is not dead and enshrined in books, but living, growing. It is the attempt to discover new facts and new relationships between known facts. A university is not a university if this is not understood. You must be one of the seekers, else you'll be left behind.
Way back in 1907, a handful of Indians were still struggling to create a niche for themselves in areas dominated by the British. There was no scope for a scientific career, as there is now in post-independent India. So Raman decided to do the next best thing, join the government. Topping the entrance examination to the Financial Civil Service, he was appointed Assistant Accountant General, the youngest ever to be so appointed. This was a period of great change in his life, for he also happened to meet his future bride, Lokasundari. The couple were married, and on Raman's posting, moved to the bustling capital of the Raj, Calcutta. But Raman had not lost his interest in research, and one day, at 210 Beau Bazaar Street, he stumbled upon the Indian Association for the Cultivation
I would
of
like to
Science.
meet the person in charge.
Ashwin, come in.
What did you say your name was? I will write it down.
C. Venkatraman. I'm a government servant. The Assistant Accountant General, in fact. But I'm interested in continuing to do my research in my spare time. Original investigation in optics and acoustics.
Well, come with me. You see, we do have a laboratory, but it's so decrepit. You know why? Because in the 30 years since it was built, no one ever came to me and said he wanted to do research.
The epitome of science in our country.
This place was built with many hopes by my uncle, Mahendralal Sirkar, a staunch nationalist. He believed that science can change people's way of thinking. He started lectures. They became very popular, but no one was interested in anything beyond that.
I would like to do my research here.
You would?
But only after office hours. I can't let the timings clash.
Of course, of course. Ashu Babu will be here to help you. But you will want something. An honorarium? Our funds are low. And I'm afraid I can't afford to pay you very much.
You needn't worry. This is all that I need. I'll start tomorrow evening.
Thank you, Mr. Raman. Thank you. All these years we have been waiting for someone like you.
The most notable piece of work he did was on the study of the vibrations of the Indian drums. The mridangam and tabla are rather unique instruments in that they are the only two drums in the entire world which can produce a group of harmonic overtones. Raman discovered that these drums give harmonic overtones by the particular loading to which his drums are subjected. For example, the fundamental mode of vibration comes when the drum head vibrates as a whole, and the second harmonic comes when the drum head vibrates in two halves, the central line remaining at rest all the time. And the third harmonic comes from this mode of vibration with one nodal circle or two nodal diameters like this one. These two modes can combine to produce a variety of modes of vibration.
You see what I mean? Such wonderful tones. Of all the musical instruments, the veena comes closest to resembling the human voice.
Really? I've been seriously playing the veena for so many years, and I never realized it.
The strange fact is, there is a law in Western science which states that certain overtones just cannot be produced by any musical instruments. But the veena violates it. You know why? All because of this curved bridge, whereas Western instruments have flat bridges. How much our ancients knew about acoustics. Do you know something?
What?
The Germans have asked me for an article.
Uh-huh. That's good.
Yes. It's just not enough to do research anymore. You must publish the results immediately.
So emanated the first research papers from the IACS, 30 years after it had come into existence. During those early years, Raman worked for the most part alone. Even so, the publications poured out. In fact, so fired was Ashu Babu by Raman's enthusiasm that even he wrote a paper for the Proceedings of the Royal Society. And Ashu Babu had never even been to college. Raman's fame began to spread. Not only did he become a source of inspiration to young research scholars like Venkateshwaran, Ganeshan, and of course, K.S. Krishnan, but Sir Ashutosh Mukherjee, the Vice-Chancellor of Calcutta University, offered him the Pallet Chair of Physics at the University College of Science. He accepted this post gladly, even though it meant receiving only half the salary that he earned as the Assistant Accountant General.
Why is the sea blue? Lord Raleigh had said, it is simply the blue of the sky seen by reflection. But looking at the deep color of the Mediterranean Sea on my way to England in 1921, I began to doubt him. So I decided to use a simple mode of observation, to view the surface of the water through a Nichols prism at approximately the polarizing angle with the surface of the sea. The Nichols prism quenched the reflection of the sky, and to my surprise, the blue of the sea became even deeper. Thus, it was very clear the color of the sea is a distinct phenomenon in itself. But what diffracts the light and makes its passage through water visible? Could the diffracting particles be, at least in part, the molecules of the water themselves?
Raman found out that the sea is blue chiefly because the molecules of water scatter sunlight. Inadvertently, a whole new area of research had opened up. It triggered off an exciting series of experiments, which after 7 arduous years culminated in the discovery of the Raman effect. On that historic day, March the 16th, 1928, Raman gave his first public lecture in this very hall to propound his theory. It was called A New Radiation.
I propose this evening to speak to you on a new kind of radiation, or light emission from atoms and molecules. To make the significance of the discovery clear, I propose to place before you the history of the investigations made at Calcutta which led up to it. In 1923, it was K.R. Ramanathan who noticed the strange phenomenon while he was studying the scattering of light in liquids.
Professor Raman, this green filter, it's complementary to the violet, so it cuts off all the violet color passing through. But when I place it here, in the path of the scattered light, the result is not the same. There's a track of light visible.
A track of light, in spite of a complementary filter. Why?
I don't know. I suppose it's a weak fluorescence due to impurities still inside the liquid. I'll have to purify it even further.
What do you think, Krishnan? I don't know. I've investigated more than about 60 liquids. Among them, not only water, but some alcohols too show the fluorescence quite markedly. But what puzzles me is, whereas fluorescence is generally unpolarized, the scattered light here is polarized. I'm beginning to wonder, is it fluorescence at all? Because if it's not fluorescence, then it should be scattering. Because Rayleigh scattering can be polarized, and it would be strong. Whereas the track that we have over here is so very feeble. Could it mean, is it not possible that it's not fluorescence at all, but altogether something new, something different? Not fluorescence, not Rayleigh scattering. You mean a new kind of radiation?
Sir, I've just studied the visible radiation excited by ultraviolet light in pure dry glycerine. It's strongly polarized.
What?
And the track is a brilliant green instead of the usual blue.
Green. A change in wavelength and polarized. This definitely cannot be fluorescence. This is something new. Boys, remember, I'd always said there must be an optical analog to the Compton effect. Is this it? You mean, when X-rays are scattered by atoms, there's a change in frequency? Exactly. Just imagine, if there's a change in wavelength with the scattering of X-rays, I think the same effect can take place with the scattering of visible light. But how do we prove it? The track that we have is too feeble. We should try and make it stronger. Probably we'll have to use a larger lens and complementary filters. Krishnan, I think you should follow it up. Aye, sir? Yes. I think I need somebody who can use the sunlight throughout the day. I've got my classes and Venkateshwaran's busy working, so he can only come in part-time. Besides, you've stayed away from experimental work for too long. Not at all healthy for a scientist, huh? This is marvelous news. Just wonderful. You understand what I mean? The first step taken in the research was to find whether the effect is shown by all liquids. The method of investigation was to use a powerful beam of sunlight from a heliostat concentrated by a 7-inch telescope objective combined with a short focus lens. This was passed through a blue-violet filter and then through the liquid under examination contained in an evacuated bulb and purified by repeated distillation in vacuum. It's true of visible light, sir. It's true of visible light. There's still a track in spite of the complementary filter, sir. It's polarized. And there's a change in wavelength. But the links are still missing. How do I show that there is a change in energy or a change in frequency? Frequency, color. The spectrum, of course. The spectral lines will indicate any change in frequency. Ashu Babu, arrange for the spectroscope. Quickly, quickly! Where's Krishnan?
Not come today, sir. Religious ceremony in his house.
It's ready, Sahab, but the sun is setting. The light will not be strong enough.
Oh, dash it all. First thing tomorrow morning, huh? Next morning I could see the spectral lines, but they were not clear. It occurred to me to change the light source, to use a monochromatic light. Ashu Babu, get me the mercury arc lamp. It's so clear, Krishnan, so very clear. In the blue-green region, there are 2 sharp lines instead of 1.
What?
Yes. Between the incident line and the new line, there's a distinct dark space. The new line must be of a different frequency. It shows a change of energy.
The new line that Raman discovered indicates the amount of energy lost or gained by a photon of light when it interacts with an atom of matter. This in turn tells us a great deal about the atomic and molecular structure of that substance. It was a momentous discovery that paved the way for new research in almost all branches of science. V Raman was awarded the Nobel Prize for Physics in 1930. It was a moment of great significance, for not only was it a tribute to the man, it also officially put a country struggling for an identity on the scientific map of the world.
Today, it is being used to solve important problems, not only in one branch of science like physics, but in many, many branches of science, almost all branches of science, chemistry, biology, material science, earth sciences, and so on. Even on application sides, it is always a part of analytical technique which is used for high technology. For example, in microelectronics, space, nuclear fusion, optoelectronics, you name it.
The man was once the center of scientific activity in India. He is now a recluse, perhaps because success inevitably breeds envy. When Raman was appointed to the Palit chair, the impression began to be created that he was a has-been physicist working on highly dated problems while a new wave of physics was sweeping the rest of the scientific world. Raman's own nature did not help. His ego had alienated many people. In the years following the Nobel Prize, the resentment against him grew more vocal. It was said that Raman did not understand the significance of his own discovery, that it wasn't even his, that it was Krishnan's.
It depends upon the point of view that you take. For example, if we ask ourselves, who was the first person who observed the Raman effect? There is no doubt that the first visual observation through a direct vision spectroscope was made by Raman himself. The question is, who took the first recorded Raman spectrum? It was K.S. Krishnan. Raman got the idea that sunlight must be replaced by a mercury arc, and Ashu Babu, Raman's famous assistant, and K.S. Krishnan adjust the spectrograph, and K.S. Krishnan developed the film. And so we could say he recorded the first spectrum. But that is not the real point. One should always ask, who got the idea? Who was behind this thing?
In 1933, Raman came to Bangalore. He'd been offered the directorship of the Indian Institute of Science. The institute had never had an Indian director. They had always been British. The institute had also never had a physics department. Raman set about creating one.
Oh, there's so much that can be done. You know something? Max Born is coming.
Sir, have you heard from him?
Yes, I've received his letter this morning. He's accepted the readership I offered him. Just wait and see, my friend. Things will begin to change for India. No more will our youth have to go abroad to get initiated into research. But as it is, I don't like the practice. The environment over there is so very different, and the conditions here makes them useless here. You know what I feel? If great men like Max Born and Schrödinger were leaving Nazi Germany, they can be provided with a home here, then perhaps there can be started off a real scientific movement in the country.
The renowned physicist Max Born did come to India, and soon Raman strove to make his position permanent. But all Raman's reforms were too sudden. They ultimately led to a major controversy.
The problem between C.V. Raman and the council leading to Raman's resignation has many facets. I shall briefly mention 4 of them. First, Raman was the first Indian director to be appointed. 3 Britishers had preceded him, and the British faculty members were rather reluctant to work under Indian director, as evidenced by Max Born's letter to Rutherford. Second, Raman had some attitudinal problems. He was an extrovert with a sharp tongue and oftentimes overbearing. He lacked administrative tact, which is so essential for a director. The third aspect, there was no physics department before Raman came. He created it and he equipped it. There were tensions and charges that Raman was building the physics department at the cost of the other departments. The Irwin Committee was not all that objective. Its members were prejudiced against Raman, and Raman ultimately tendered his resignation from the post of directorship and continued to work as the head of the Department of Physics.
Having no alternative, Raman decided to stay on. He continued to do research of a high quality in optics, crystal physics and ultrasonics, in which the Raman-Nath theory is an outstanding piece of work. But the controversy had left its scars. The problems that Raman faced in his attempts to upgrade the institute were to him representative of larger issues at stake. These included the need to recognize the importance of fundamental science, to manufacture equipment indigenously, and to make universities centers of research.
2 years before my retirement from the Indian Institute of Science, I started building my own center. I called it the Raman Research Institute. There was no water, no electricity when I first started. But that didn't make a difference. At least I could do my highly personal research work without any interference. You know what I mean? Like the poet and the painter, the scientist too is motivated by an inner creative urge. Only earlier, I felt I had to prove my findings to others. Today, if I have seen and understood, I am satisfied.
Although certain aspects of Raman's personality and work have been criticized, there is no doubt that he was instrumental in laying the foundations of the entire edifice of Indian science. Apart from physics, he was equally interested in the growth of the other fields. These fields were not to be developed in isolation, but in relation to each other. So he created a national forum, the Indian Academy of Sciences. He also wanted science to reach the masses. His popular lectures were always comprehensible and tinged with humor.
What we lack is perhaps courage, driving force. We need a spirit of victory, a spirit which will recognize that we, as inheritors of a proud civilization, are entitled to a rightful place on this planet. If that indomitable spirit were to arise, nothing can hold us from achieving our rightful destiny.
Raman died on November the 21st, 1970, here in Bangalore. He was 82. His death marked the passing of an era in Indian science. A unique memorial marks the spot of his cremation. It is, as he himself would have wished it, this solitary tree